Bismillahirrahmanirrahim. Salamun alaikum. In this video, I want to talk about the last type of NoSQL databases, which is the graph database. Graph database is a type of NoSQL database that could be used for storing data that is in the format of networks or graphs. The main point about this type of data is that we have some entities that are connected to each other. One example of this type of data is geographic locations. Geographic locations are modeled as vertices of a graph, and these locations, they could be cities, towns, or any other location. Each of the vertices, they have some properties like name, longitude, latitude. Okay. For example, if we have a city or town, the population, the size, and then in this graph, the edges are the highways and the railways between those cities. So we have a graph. The nodes are the locations, and the edges are the highways or railways between those cities. In this figure, you see that uh, we have some locations here, and these are some cities: Denver, Chicago. Okay, and these cities, they are connected to each other, and these are the paths between these cities. This is another example of graph data. It is about diseases. If a person is infected with a disease, this person, he could infect others. If the person is not infected, but he is infected in the past, the probability of the infection is 0.2. If the person is not infected and he is never infected in the past, the probability of infection is 0.8. And if the person is an immune, the probability is 0. Okay, so we could have a graph data for different in different situations. One other example of this type of data is social media. In the social media, the data that we have, this is an example. Okay, we have some users and we have some posts, and each user is liking different posts. So in this data, the user and post are the nodes or vertices, and the like relation is the connection between these nodes. One user may like one or more posts. Okay, this is a definition of graph. You are all know what is a graph, but this is just a reminder. A graph is constructed of vertices and edges. A vertex, it is representing an entity, and it usually has a unique identifier. The vertices, they could have properties. Each vertex could have properties, and this vertex, it could represent any entity. For example, it could be the people in a social network, It could be the cities that are connected together. It could be the proteins in our body that have interactions with each other, and it could be the warehouses in a company. So the vertex could be any concept, and the edges is the relation or the connection between two vertices. For example, in this example, you have the cities, and the connections is the path between the cities. Each of these connections, they have a length. This is the length of the path between the cities. In the graph is constructed of some vertices and edges. Okay. And the edges, they could be directed or undirected. This is an example of undirected edges, and this is directed edges. Path. In the graph, the path is a set of nodes and edges. A path is a set of nodes and edges. And a path is a very important concept in the graph, and in some graph operations we want to find special paths in the graph. A loop. A loop is a path that the start and the end of the path are the same node. This loop, it could start and end on the same node. This is okay, one type of loop, and the other type of loop is when we start at the node and go to other nodes and then finish at the same node. In the graph databases, we could have different operations. Some of the operations, they are similar to other databases: insert, read, update, delete. These are some of the operations which are the same for all databases. But there are some operations which are specific for graphs. For example, the union of graphs, the intersection of graphs, and the graph traversal. The union of graphs. The union of graph is a combination of two graphs. This is graph A and graph B. These two graphs, they are combined together. They are combined together, and this is the result. So union is a combination between two graphs. This combination is done using the nodes which are exist in both graphs. Intersection is another operation that we could do on the graph. Intersection means that we want to find what do the graph have in common. The nodes and edges that are same in both graphs. And another operation is graph traversal. Graph traversal. Graph traversal means visiting the nodes of the graph. Visiting the nodes of the graph. So we could have a graph traversal using different methods. So we want to visit all of the nodes of the graph to do some specific operation. Okay, for example, if we have a graph of cities, we want to find the shortest path between each two cities. So we would have a graph traversal to find the shortest path in the graph between two nodes in the graph. Okay, as we said, the graph database is used for storing data which is in the format of networks or graphs. Okay, in this example here, you see an example about videos, about movies. In this example, you see some data about the movies. Okay, you see it here. Director, movies, actors, and people. All of these are data which are related to movies. Okay, this is the movies table. Uh, this is the actors. This is the people who are in each movie, the cameraman and other people. And this is the data about the directors of each movie. Okay. In each of these tables, we have some primary keys. You can see in the table movies, the primary key is movie ID, or here is person ID. Also, we have some foreign keys. For example, in directors, the movie ID and the person ID, it is foreign key. The movie ID is referring to this table, the movies table, and the person ID is referring to the people table. So, as we said before, in the relational database, the foreign keys are used for relating different tables to each other. Okay, the, as you see here, this figure, it's like a graph. You see this graph, for example, it has four nodes: director, people, movies, actors, and they are connected. But the question is that could we use the relational database for data in the format of graphs? Could we do this? In this figure, it seems that we could do this. But what is the answer? The answer is no. The relational database, we may show some graph data in this type of database, but it's not suitable because we can't do graph operations in the SQL language. The SQL language is the language we use for doing operations in the relational database. In SQL, we don't have graph operations. Okay, so this is an example of an operation that it could be done in the graph database easily, but uh, in the relational database, the operation is done like this, and this is a very long SQL command which takes much time to execute. So the relational database could not be used for graph databases. One of the advantages of the graph database is that the operations and the queries are faster because in the graph database we don't have joins. In this figure you see a figure about a relational database. In this database we have free tables, students, courses, and enrollment. Data about the students, the courses, and the enrollments. Uh, the enrollments are a relation between the courses and the students. Okay, so we have three different tables. When we want to do an operation on this data, we have to join these tables so we could do the operation. But in the graph database, the data is like this. Okay, these nodes are for the students and these nodes are for the courses, and these are the connection, the relation, the relations between the students and the courses. Each student has enrolled in a course. So as you see here in the graph database, which is storing data like a graph, we don't have joins, so the operations are faster. The next advantage of graph database is that we have a simpler modeling of the data. If in the previous in this example you see that if we want to use a relational database for storing the data about the social networks, the people data, the posts, and the likes. Okay, this is the data that we have in the social network. Okay, so we have three tables. First, we have to model the entities which want to be connected, which are people and posts. And then we have to model the interactions between these two entities, which is the like relation between the two entities, people and post. This is what we do in the relational database. But in the graph database, it's very simpler. We only have some nodes and some edges. The people and posts are the nodes and the like is the edges. So the modeling of graph database is simpler than relational database. And one of the other advantages of the graph database is that we could have multiple types of edges between two nodes. For example, here you see the nodes are two cities, Chicago and New York. And as you see, we have three relations between these two cities. The first one is for the railway path, the second one is for the airplane, and the third one is the road between the two cities. So we could have multiple relations between two entities. This is one of the advantages of the graph database. And we have two types of graph databases, the RDF and the property graph. RDF stands for Resource Description Framework. This is one type of graph database, and the second one is the property graph database. Okay, the RDF, it is a special format that's used in graph databases. RDF, it has it is a type of data which has three parts, triples, and it entity, attribute, value. Okay, entity, attribute, value. For example, movie. The matrix is movie. The entity is movie. The attribute is, and the matrix is the value. Okay, so RDF is that special type of format which is used in RDF graph databases. And these are some examples of graph databases: Allegro Graph, Autotext, GraphDB, Stardog, and Oracle Spatial. Also, there is a language for doing operations on RDF graph databases, which is called SparkQL. SparkQL is a language for doing operations on RDF graph databases. Property graph database. Property graph database is a type of database which could be used for storing property graphs. In this type of database, we could store data which is in the format of property graphs. Neo4j is a type of property graph database. It is based on Java, and it could be embedded with any Java application. In this Neo4j, we have different languages for doing operations. For example, Cypher and Gremlin. Cypher is a language which is non-procedural. It means it is near to the human language, natural language. And Gremlin is a language which is more procedural. These are two different languages we have for doing operations in the Neo4j database. This is an example of the Cypher language. The Cypher language is a query language for Neo4j, and in this Cypher language, this is the example here. Okay, this is a property graph here about the movies. Okay, we have the movie, the person, also the movie, the person, and this is the edge or the relation between the two nodes. If we want to create this property graph using the Cypher language, we have to write these commands. Okay, and then if we want to do some operations on this graph data, we could write this command, which is a bit similar to SQL language. And also the next language I said it's the Gremlin language. The Gremlin language is it is more procedural. It is like a programming language. If we want to create this property graph in using Gremlin, we have to write these commands. And then if we want to do an operation in this graph database, this is an example of this. Okay, so this was my topic about the graph databases. So graph databases could be used for storing data which is in the format of graphs, and then we could do graph operations on the data. Thank you very much.